Well, you thought you'd never see this thing again. This is my 20 dB attenuator that turned out not to be attenuating below 700 megahertz, so I converted it to a 250 watt dummy load. Let's see, originally it was a 100 watt attenuator. Yeah, 100 watt attenuator at 20 dB, but it only worked at 700 megahertz to 2.7 gigahertz. So there are videos about that. Go back and watch those videos if you're interested. I still was disappointed that I didn't get what I wanted. What I wanted was a 20 dB attenuator, and this was going to be a 100 watt attenuator, which is great because I think I have a 30 watt attenuator, but it's not enough, and I wanted a 100 watt attenuator. A 20 dB attenuator is a factor of 100, so if you put in 100 watts, 1 watt comes out the other side, which I could run into my machine just fine. I was still disappointed, even though it's now functional as something. You know, there's a lot of room inside this thing. If you remember those videos, there's a lot of spare space in here. This is a big thing. It was much bigger than, when I got it, it was much bigger than I thought it was going to be. I thought it was going to be about yay big. I found these on eBay, and I will zoom in, but that is a 250 watt 20 dB attenuator. These came from Henry Radio, very old name in ham radio, and yeah, it's brand new. It's a Florida RF device, in and out. It should be exactly what I need. I have a lot of room in here, so I thought what I would do is I would add, let's take these off. I would add 2 more connectors somewhere, another in and out, so I'll have one in and out that's the attenuator, the dummy load, and then I'll have one in and out that's a 250 watt 20 dB attenuator, so that will be great. Let me zoom you in so you can take a look at that thing. Okay, wow, we're really zoomed in here. This is the part, and there are these 2 tabs that go out. And so I'm going to do the similar thing. I'm going to make 2 PC boards that have some traces on them that I can solder the wires to the connectors, and then this will solder those to keep everything nice and stiff, and should work out great. I paid $34 for the for this chip, which is a pretty good deal. Now that I have $40 invested in the big heatsink and about $35 invested in that it's about the same as what it would cost me to get a. It's about the same as it would cost me to get a 100 watt attenuator, but I'll end up with a 250 watt attenuator. So yeah, pretty good. Alright, I've taken the screws out, and let's take a look inside. And what I want to do is I want to figure out where we have room to mount this new section. Looks like there's a lot of room in the back here. Right along here, if we have if we put one here, maybe even one on the side. Might be better. We could actually go this way too. We could go in and out this way. We have in and out this way. Maybe in and out this way. I'll figure that out. But anyway, there's lots of room here for connectors along the sides here. Probably easiest along the side, but we'll see. So before we had this little pedestal here that we reused to mount our load resistor. We have a little pedestal here that the coax was wrapped around. Let's pull this off. Let's see, would this go on there? Sort of. I certainly could mount this on that pedestal if I milled off these edges here. Oops, can you see that? I'm sorry. If I milled off these edges, I could mount the attenuator down there. But then I wouldn't have any ways to mount these little PC boards that have the kind of need a bigger area. Well, yeah, I guess I could mount these on standoffs. Yeah, I could probably make little standoffs for those. So that's probably pretty good. So let me mill these fins off so we have a nice flat area here to mount that attenuator to, and then it's in intimate contact. This is all one piece of aluminum. It's just a billet that's been milled out. You can see the milling marks here, so be good thermal contact if we mount it to this post here. So you'll get this into the mill and remove these fins. All right, I've taken off the vise so I can get to the bed here, and I'm going to just put some toe clamps on here, and that should do the trick. So that should hold me nice and rigid, and we'll come down with the cutter and level this off. So let me get it clamped down, and we'll do some cutting. That's pretty solid. That should do the job. Alright, let's figure out what kind of cutter we want to use on this. Let me go find one. I've got a big face mill here. I thought that's too big. Seems a little big for the job. I'll get a different cutter in there. Yeah, this is a face cutter I've got. I think it's a 2-inch face cutter, and I just don't think it would be very good for the job. So we'll get something like a regular end mill and come in here. I don't think we need anything that big. Alright, just get off the major bits there. So now we can come in and mill this proper. Alright, how does that look? That should work. Nice and flat. Alright, so we have this nice flat pedestal now. And it's a great size for the attenuator. We'll have our little PC boards mount out here. I'll build little standoffs for those of the right height. I'll just measure this pedestal and, oh, and actually I need to cup a little higher than the pedestal because this is thinner. I'll make a little standoff here, make two identical ones for the other side, and drill and tap those, and that'll give us a great mounting. Alright, this is a little block that I made. It's a steel block. It has some holes for quarter 20. This is 632. There's 8, 10, and 4 size taps. It's just a nice little widget to help you get your tap started straight and make sure your threads are going in the right direction. Nice little tool to have. You can buy some pre-made, but they're usually really big. This is just a nice little one that you can get into spaces. So there we go. I've got 2 holes tapped, so we should be able to put our attenuator down. All right, so ready to put down our part. We're going to use some thermal compound. That on this part here. That should be enough. All right. I have these little Exolite hex screw, and they have a big handle that you can put on them so you can get a little more torque. So squeeze these down. Looks pretty good. Okay, let's figure out how high we need the standoff to be. And you haven't seen these before, these are really clever little things. They're little adjustable parallels that you can get. Have a little locking screw on them. And then you can slide them up and down so they get fatter or they get skinnier. And so I figure we'll go ahead and use one of those. Snug it up so it just moves. We can put our little board on it. Oops. Put our little board on it, and we can slide it under and adjust its height so that we're about the right thickness. I'd say about there. All right. So we want to keep that. So I'll lock down that little screw, and let's double check it. Yeah, that will be very nice. So we'll have one on this side and one on this side. So all we need now is to make a little standoff exactly that thick. Okay, I found a piece of 6061 aluminum, and it's got about the right. It's about the right size here. So we'll have enough to balance our little part on to put a screw in there, and it certainly meets the height requirement. So put this in the mill, and we'll mill it down to the correct height. Put some holes in it, slot it or cut it in half. Then so we'll make two identical ones. So I'll mill it and everything first, and then I'll cut it in half as a secondary operation. All right. So I've milled down the thickness of this bar here, so it matches the thickness of the parallel. So now we have the correct thing. And now what we need to do is mark this for length. Yay. So I will cut that off and then mark another one, cut that off, so we'll have two pieces, and go from there. Alright, so we have two little blocks now of the right height, and they'll go on something like that. So we'll have a block over here, block over here. I'll drill a through hole on the blocks and drill and tap a hole in the heat sink, probably 440, and all right. I think what I'll do is I'll mount this connector over here, have it come straight across, and then the other connector I'll mount over here somewhere. Have it loop around. Maybe I'll use some of this coax I have left over, and we'll actually have a real 20 dB attenuator. That'd be great, and 250 watts. So the whole thing will be 250 watts. So that'll be really nice. All right, so I've poked a couple holes in the bottom, or in the side, I mean, for the connectors. One will go there, one will go there. I still need to tap the. No, I've tapped them. So I need to find some wire. This one will be easy. A short little jump here over to the connector here, or the strip line here. And then this one is going to have to snake around, so I think I'll find a piece of that coax and attach it here. Figure out how to attach it to the. I think I can solder directly onto here. I think I can do that. So I'll put that on next. Okay, this is how I ended up. There's a bare wire here going from this connector to this pad. Same as over here. It's just a bare wire. And on this side, it goes into coax. I have the braid of the coax soldered here to this PC board. which has a screw on it which does attach to ground, so it is an RF ground. And then back in here I soldered the braid to the connector, and so there's an RF connection back here as well. So I actually have a little piece of coax there. And let's see here, let's measure what's going on. Get out my ohm meter. There we go. So on the input, we have 51 ohms, and on the output we have 51 ohms. And from connector to connector we have 82 ohms. So we are ready to go. I think what I'll do is I'll take this over to the tester and put in a signal and measure if it's really 20 dB. It'd be a shame if it isn't. All right. So we have what are we doing here? We have in and out. Let's calibrate this. So we'll run it straight through. We will. So now we have a 0 line up at the top there, and we will run that into the 20 dB attenuator. And there we go, 20 dB, 10, 20. So let's get a marker. And we go. We can read the dB here, minus 19.38, minus 19.7. So here frequency, let's go here to 7 megahertz, nice handband. We're at minus 19.38. 14 megahertz, we're at minus 19.38. 21 megahertz, we're at minus 19.7. So yes, very flat, very nice. 20 dB, 250 watts. Yay. Okay, so what did I end up with? I ended up with a 250 watt, 50 ohm load on this side. And on this side, I have an RF tap that comes out of that 700 to 2.7 gigahertz coupler. And I've also added an actual 20 dB attenuator. 20 dBs in, 20 dB out. And so now I have a very useful piece of equipment.